Alrighty, in your books on page 723, we're going to be doing some kind of bouncing around, doing different things. So if we are on page 723, notice and wonder. Remember, this is just for you to do. I notice, blank, I wonder, blank. Whatever you might notice or wonder, that is up to you. It's whatever you notice or wonder. Next, we have a line. Estimate the length of the line to the nearest unit. Okay, well, my line is that long. Now if I, go and put this on 0 and line it up. It's about here. So here's 2, 3. It's kind of in between the first and the second line. So 3.1 to 3.2 somewhere in that area. Next, find the exact length. This is where we're going to be doing some math. Oops. Just throwing stuff around. Okay. So yesterday we saw making a square out of our line. So that's what we're going to do. Here's going to be one edge of our line. It goes over 1 up 3. Rotating, I'm going to go up 1 over 3. So I still make a 90-degree angle with my two lines. Okay. There, up 1 over 3. Here is my square. Because our square is not on an axis or any of these lines, I'm going to draw that bigger square around it to figure out what the area might be. So we have our big square. We have these triangles that we're going to be taking away eventually. So we have to do a couple things. What is the area of the big square? Remember, area is equal to your side length squared. 1, 2, 3, 4. So we have 4 squared. 4 times 4 is 16. Now we're going to take our triangles away. Each of our triangles has a match to go with it. So if I put this triangle and this triangle together, it makes a square. And we have 2 of those. So this times 2. One of these is 3 by 1. Well, 3 by 1 means it's an area of 3. And I have 2 sets of those. So that means the area of my triangles is 6. And I need to take them away. So that means my pink square has an area of 16 minus 6, which is 10. To find area of a square, it's still side length squared. So to figure out what your side length is, we need to figure out what is the square root of 10. If you look at your sheet from 2 days ago that you created, or maybe you created yours yesterday, you would see that 3 squared is equal to 9. And 4 squared is equal to 16. So that means it is somewhere between 3 and 4, but closer to 3. The exact length you wouldn't convert this, you wouldn't answer this problem. You would leave it as square root of 10 because that's going to give you the exact number. Because when you find square root of a non-perfect square, it's going to give you a decimal and it's going to be rounded. So our exact length would then be 10. So next we're going to go a couple pages. 726. So we're doing the same thing. We have two different diagonal lines that we need to create squares out of. So for this first one, AB, it has 1, 2, 3, 4, and over 1. 1, 2, 3, 4, 1. One, two, three, four, 1. So we have, what does AB equal? We have the pink square, we don't know yet, and we will have an orange square around it. And we will have our yellow triangles. We have our orange square, which is bigger. And we will have our yellow triangles. And there's 2 of them. So our orange square, the biggest one that we have, is 1, 2, 3, 4, 5 by 5. 5 times 5 is 25. Our triangles are 1, 2, 3, 4 by 1. Well, 4 times 1 is 4. So that means this is 4 and this is 4. So 4 times 2 is 8. Should have done my small triangle below it. 25 minus 8 is 17. So that means the little square has an area of 17. So that means, which is equal to our side length squared, the square root of 17. Well, we know, 3 squared is equal to 9, and 4 squared equals 16. We go to the next one, 5 squared equals 25. These two we knew from the page before. We need a little bit higher, so that means our number is going to be somewhere between 4 and 5. Closer to 4 than 5 because 17 is closer to 16. The exact answer, though, would be that square root of 17. Okay, for the next one, GH. Over 4, up 4. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Let me grab a couple more colors. So in this case, it's the little square. And then we will have the big square. And then we also have our triangles. I'm glad we did the small one first. Times 2 of them. Okay, our big square is 1, 2, 3, 4, 5, 6, 7, 8 by 8. 8 times 8 is 64. When we add up our two triangles or put them together, We have a 1, 2, 3, 4 by 4. 4 times 4 is 16. 16 times 2 is 32. And then we need to take our triangles away from the big square. 64 minus 32 is 32. So that means GH is root 32. Because your area is 32 and your area is equal to side length squared. The opposite of squaring is 2 square root. 32 is not a perfect square. We know 5 is 25. Next would be 6 squared, and that's 36. So that means it goes in here somewhere. It's a little closer to the 6 than 5, but that is that. Next, we are going to page 729. Decide if each statement is true. So squares and square roots are opposites. They undo each other just like adding and subtracting are opposites and undo, or multiplying and dividing are opposites. They undo each other. So if I were to have the square root of 5 squared, they are opposites, so that means they cancel each other out. So I now have 5 is equal to 5. That one is true. The square root of 9 squared, they cancel each other out. 9 is not equal to 3. Number 5, we have 7 equals the square root of 7 squared. Those two cancel out, which is a true statement. Next, sorry, I went in the wrong order. That's okay. Does not really matter. We have the square root of 10 squared. Again, they cancel each other out. 10 is not equal to 100. The square root of 16. It's not squared or anything. Square root of 16 is 4. And 2 squared is also 4. So that means that is a true statement. Next, what two numbers does each square root lie between? Be prepared to explain. So if you don't have your paper, we might need to write a couple of these out. So let's go with, I'm over here, 98. 2. I'm probably going to have to do 2, 3, 4, 5, 6, 7, 8, 9, and 10. The square root of 100 is 10. 81, 64, 49, 36, 25, 16, 9, and root 4. So these you should already have. You should be using your sheet of paper you got the other day where you filled out, and it should be in your book somewhere. So does root 7, what number does it lie between? Well, if we're looking at all these, 7 is somewhere between here because we have 4 and we have 9. So 2 and 3. Root 23. 23 is less than 25, so 4 and 5. 50 would be between root 49 and root 64. Where are my numbers again? 7 and 8. And then 98 is in between 81 and 100. So 9 and 10. Can we do any better than between 3 and 4 for root 12? Explain why, a way to figure out if it's closer to 3.1 or 3.9. So 3 and 4. So 3 squared is 9. So root 9, equals 3. And square root of 16 is equal to 4. is which is 12 closer to? So let's draw a number line. Let's 9, 10, 11, 12, 13, 14, 15, 16. So here's root 16. Here's root 9, 10, 11, 12. This would be root 10, root 11, 13, 14, 15. You can't see any of that. There we go. So here's root 12. 3.1 or closer to 3.9. We don't know where 3.1 and 3.9 are. We only know that this is 3 and this is 4. This would be 3.5 because it's halfway in between the two. This would be 3.25, 3.75. So breaking it down to that, we can still see, or we can see that it is less than 3.5, which means it is going to be closer to that 3.1. You can do that with any number. You would find your perfect squares or your perfect roots, write those numbers, and then split it in half and in quarters. Write down all your square roots at the bottom. It's time consuming, but it can be done. Next, explain how you know the square root of 37 is more than 6. Well, can't have both of these. You should have these on yours. We know it's a little more than 6 because that should be an A. Root 36 is 6. So you would do the same thing. You can type in your response. We know square root of 95 is a little less than 10 because the square root of blank is 10. So you will type in your responses for those two. Same with this one. How do we know it's between 5 and 6? Well, because the square root of 25 is 5. Square root of 36 is 6. 30 is in between those two. Something along those lines. Plot each number on the number line. 6. Easy enough. 83 is not a perfect square root. 40 isn't. 64 is 8. So we got that one. We got that one. And then 7.5. Okay, square root of 83. If we're looking at this, 83 is just above 81, so we're going to be just above 9. So, I don't know, maybe there. Square root of 40 is between 36 and 49. So somewhere between 6 and 7. But closer to 6 because it's only 4 away from 36. So closer to 6, maybe here. Maybe we should have wrote those. This is root 40. This is root 64. And this is root 83. That is it for the book portion of your video. The next portion, you are going to need your new packets. And we're going to just talk about triangles and parts of a triangle for our new formula that we will be using tomorrow and such. All right, so it's this page right here. Parts of a triangle. Of a right triangle. Very specific. It can't be any triangle. It does need to be a right triangle. So there are three parts of a right triangle. We have A, which is a leg. B, which is also a leg. Lep. I don't know what I was doing. A leg. And C is the hypotenuse. So A and B, they are interchangeable. Either one, it does not matter. They do need to be touching each other and connected to the 90-degree angle, your right angle. So that means this is your leg and this is your leg. You could have B and A. Your hypotenuse is across from your right angle. So this would be your C. So legs are adjacent to right angle. Hypotenuse is across from your right angle. So you should be able to answer all these. I'll do one more. I'll do this one right here. Here's my right angle. Right angle is 90 degrees. So we have A, we have B, we have C. C is across from it. And A and B touch each other. Try these three. 1, 2, 3. Next, the theorem. Why does this work? So we have A. We have B. And we have C. To find your side length, I'm going to switch that to this color actually. So we need to figure out what is this side length. Well, we know A has a side length of 3. And when we square it to figure out its area of a square, we have 3 squared. B, we have a side length of 4. When we find the area of a square that it makes, we square it. C, we don't know yet, but we are going to prove it in just a minute. So 3 squared is 9. 4 squared is 16. It is saying that whatever number we have here should end up having an area of 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 25 there. So that is true. In this, we know 9 of them are A. And do we have 25 left over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, not 25 left over, 16. Because this is an area of 16. So this should be 16. Sorry, guys. The side length of this one, you can count out. There are 1, 2, 3, 4, 5. And 5 squared is 25. The formula, the theorem is that A squared, or one of your legs squared, plus your other leg squared, equals your hypotenuse squared. So the next page, if I were to give you a triangle, I want everybody to plot the first point at 4, 3. So this is at negative 4, 3. Negative 4, 3. This next one is going to be negative 4, negative 1. So down here. And your last one, way over here, I'm going to write it right here. So we know that this one goes here. We know this one goes here. This one is 5, negative 1. And that one goes there. If I draw my triangle, I'm going to use a marker. We are able to find the lengths of all of these sides using our formula. So we have A. A is a distance of 1, 2, 3, 4. So that means we have 4 squared. B, 1, 2, 3, 4, 5, 6, 7, 8, 9. So A, B should be equal to C squared. We don't know what C squared is yet, though, so I'm just going to bring it down. Yeah. It's almost like it's a little too big. So we have our triangle. We know that this one is 4, and we know that this one is 9. So let's figure that out. 4 squared is 16. 9 squared is 81. We're going to backtrack just a little bit. I'm really sorry. We're going to take this away 1. So that means B is now 8. B is now 8. That means this is 64. It's going to give us a little bit of a nicer number. Sorry for the scribbling. You'll survive, though. Still equal to C squared. 16 plus 64. Oh my goodness, guys. That doesn't give you a happier number. Man. It's okay. We're just going to work with this. 16 plus 64. 6 and 4 is 1. Carry 1, so that gives us 80. The opposite of squaring is 2 square root. 80 is not a perfect square, so we aren't going to get the square root. It would be between 9 and 10, though. Nine is the square root of 81. 10 is the square root of 100. For some reason in my head, I thought that I was going to get 100 here, but this would have had to be 36. It is what it is. So we'll practice one with a perfect square. You probably don't have room on the backs. Hopefully you have room right here. If I were to have a triangle where the numbers were perfect, it could be can't use the one from the front where it was 3, 4, and 5. It could be, we could go with what I was trying to go with here, where it would be 6 squared and 8 squared. Well, 6 squared is 36, plus 8 squared is 64. 6 squared plus 8 squared equals C squared. Where 36 plus 64 is 100. That's equal to C squared. The square root, to undo those, square root of 100 is 10. we will have more practice on this. You'll be getting another new packet to go with. That some of it will be review, but that will be tomorrow. Hope you were great today.